Hi guys, I trust that you're feeling well and awesome. Welcome to this video on grade 10 mathematics, and in this video we're going to have a look at factorizing a sum and difference of two cubes. This is the third video in our series of factorization, covering the basics of what factorization is and the different processes involved when factorizing different types of expressions. In this video we'll have a look at what the difference in sum of two cubes is, how to identify it from a question, and also how to factorize the sum or difference of two cubes. Without any further ado, let's get straight into it. As we've mentioned in the past two videos, factorization is the process of finding the products or factors of a given expression. Now, if you haven't watched the previous videos on the common factor and the difference of two squares, I would highly suggest that you go have a look at it and then come back to this video so that you follow the process in order of how to do the given factorizations, because there are cases in which you have a sum or difference of two cubes that needs a common factor factorization, or there are cases in which you've got the sum or difference of two cubes that need you to use the difference of two squares as well. So, as we said, the method of determining the products or the factors, it depends on the type of equation that you have. It depends on the type of expression. And we have said the different methods of factorizing are the common factor. We looked at that in the first video of this series. We looked at the difference of two squares. That was the last video in the series. And in this video, we're going to have a look at the sum or difference of two cubes. We'll have a look at grouping in a later video, and also we'll finish off everything by looking at how to factorize a trinomial. So, let's get into today's business. The sum or difference of two cubes. What is this? Well, the sum of difference of two cubes is identified by two terms. Two terms, and that's because we said the sum or difference of two cubes, so we must have two terms, just like the difference of two squares that we covered in the previous video. Both of these terms have to be perfect cubes, and unlike the difference of two squares, these may have the same or different signs. You would remember that we said with the difference of two squares, we need to have two different signs. And the two terms have to be perfect squares. Now that we're looking at the sum or difference of two cubes, both terms have to be perfect cubes, and they can have the same or different signs. Now, what is a perfect cube? A perfect cube is any number or term that can be expressed as having an exponent that is divisible by 3. For example, I can have x to the power 3, this is a perfect cube. I could say y to the power 6, this is a perfect cube. I could say k to the power 9. I could say a to the power 12. I could say b to the power 30. I can even say something like m to the power 120. For as long as the exponent is a number that can be divided by 3, we consider the term to be a perfect cube. I hope that this makes sense. Please take note of it. So let's say we have an expression in the form x cubed minus y cubed. Both of these terms are perfect cubes, and they have different signs, so it's a difference of two cubes. What would we have here? Our factors would be x minus y into x squared plus xy plus y squared. Let's go to the writing pad and let's actually see how we came to these answers. So, looking at this, I've written it side by side, the sum and difference of two cubes, but let's start with the difference of two cubes. So what we need to do is we need to have a small bracket, and then we need to have a big bracket. Now, the small bracket always takes the sign of the original expression, so this is going to be a minus. If you have the minus in a small bracket, then you must have two pluses in the big bracket. Okay, now coming to finding the terms. To get the first term in the small bracket, you will take the first term of your expression x cubed, and you will find the cube root of it. The cube root of x cubed is just x, so we put x there. Next, we take the cube root of y cubed, and that gives us y. Perfect. Now for the next section, I need to use the small bracket. To get the first term in the big bracket, I take the first term in the small bracket and I square it. X squared is going to give me x squared, so I'll have x squared there. To get the second term in the big bracket, I have to multiply the two terms in the small bracket, and this is going to give me xy. Please take note that you have to ignore the negative sign. So I'm going to put xy there. To get the last term in the big bracket, I take the last term in the small bracket and I square it. Y squared is just going to give me y squared. So there we are, I've got y squared there. We are done factorizing the difference of two cubes. Let's look at the one on the right hand side. This is the sum of two cubes. Once again, I'm going to have a small bracket and I'm going to have a big bracket. Small bracket always takes the sign of the original expression. If we have a plus in the small bracket, then we must have a minus and a plus. Please take note, the order is always the same, whether you're working with a sum of two cubes or a difference of two cubes. So for a difference of two cubes, your brackets will always be minus, plus, plus. For the sum of two cubes, your brackets will always be plus, minus, plus. Always, irrespective of which terms you're working with. Please take note of this. Once again, to get the first term in the small bracket, I take the cube root of my first term in the expression. Cube root of x cubed is x cubed. Sorry, this is just x, not x cubed. So I'm going to put the x there. Next, I'm going to take the cube root of y cubed, and that's going to give me y. Right, I'm done with the expression. Now to get the first term in the big bracket, I take the first term in the small bracket and I square it. This gives me x squared. I put x squared there. To get the next term in this big bracket, I take the two terms in the small bracket and I multiply them. X times y will give me xy. To get the last term in the big bracket, I take the last term in the small bracket and I square it, and this is going to give me y squared. So I've got y squared there. Awesome, wonderful, life is great. I hope that this makes sense to you guys, and I hope you understand what we're doing here. If you do enjoy the content, if you're learning something new, please give us a like, please subscribe to the channel, click on the bell icon so that you will receive updates every time when we release a new video. Most importantly, please don't be shy. Please share this video with other people. Please share the channel with other people. Please share the playlist with other people so that they can benefit from the same knowledge that you are learning whilst going through this content. Perfect. Let's go back to our notes and let us look at the rest of the content. So we've already factorized our difference of two cubes. We've factorized our sum of two cubes in the working just now. Now notice we have said that the order of the signs is important. As I said to you again, if it's a difference of two cubes, you're always going to have minus, plus, plus. If it's a sum of two cubes, you're always going to have plus, minus, plus. So in both of these instances, you always have two positive signs and one negative. How do you determine which one is which? Small bracket always takes the sign of the original expression. Awesome. Let's look at some examples. So there's the first example. We have k cubed minus 64. Let's go to the writing pad. Let's scroll down for some room here. And we are looking at k cubed minus 64. So the first question you need to ask yourself is, are these two terms, well, yes, these are two terms. Are these two terms perfect cube? Well, think about it. Are they perfect cubes? Let's see. I can write k cubed as just k cubed, that's fine. But 64 can be written as 2 to the power 6. Now notice that the exponent of 2 is divisible by 3. So this is a difference of two cubes. To factorize, we said we're going to have a small bracket and a big bracket. The first bracket, the small bracket, takes the sign of the original expression, followed by two pluses in the big bracket. Okay, so to get the first term in the small bracket, we say, what is the cube root of k cubed? This gives us k. So let's put in k there. To get the next term, we will say what is the cube root of 2 to the power 6. If you remember from laws of exponents, this is going to be 2 to the power 6 divided by 3, which is going to give you 2 to the power 2, which is just 4. We've got 4 there. Moving right along, now we need to get the terms in the big bracket. So I'm going to say, okay, fine, let me take the first term in the small bracket, let me square it. So k squared, that's going to give me k squared. I've got k squared there. Next step is to multiply the two terms in the small bracket. K times 4 is going to give us 4k. Remember, we ignore the negative sign. Lastly, I am going to take the last term in the small bracket and I square it. So 4 squared, this is going to give me 16. I put the 16 there. If you want to check if your answer is correct, you could just multiply out the products and see if it's going to give you k cubed minus 64. And for that, please have a look at our video on products. I will put the link down in the description so that you know exactly how you would go about finding the product of the specific expression. Please take note, this is a product of a binomial and a trinomial. Wonderful. We are done factorizing this. Let's look at the next equation. So in our next expression, we've got 27 plus m cubed. Let's go back to the writing pad. So we said here we've got 27 plus m cubed. Are these perfect squares? Well, 27 can be written as 3 to the power 3, so that's a perfect cube. And then this is m cubed. I can rewrite this as m cubed plus 3 to the power 3. There's no specific reason for doing this, but I just prefer to have my variables first and then the numbers after if it's a case of having variables and numbers. If you factorize it using 3 cubed plus m cubed, your answer will be exactly the same. Okay, since we've got a sum of 2 cubes, we know we must have a small bracket and a big bracket. Small bracket takes the sign of the middle term. We have minus, we have plus. Okay, let's look at this. To get the first term, we say the cube root of m cubed, that's our original expression. This is going to give you m. Let's put m there. Now, the cube root of 3 to the power 3, from laws of exponents, this is 3 to the power 3 over 3, which is 3 to the power 1. This is just 3, so I've got 3 there. Next, I need to get the terms in the big bracket. I'm going to say, okay, let's take the first term that we have in our small bracket and let's square this. So m squared, this is just going to give me m squared. So let's write m squared there. We have m squared. Next, I multiply the two terms in the first bracket. So m multiplied by 3. This is just going to give me an answer of 3m. So I've got 3m here. Lastly, I need to take the last term in the small bracket, which is 3. And what I need to do here is I need to square this. 3 squared is going to give me 9. So I have 9 there. Wonderful. We are done factorizing this. Let's move on to the next question. This one is interesting. We've got negative p cubed minus 216. So let's go back to our writing pad and let's look at this question. We have negative p cubed plus, this is minus 216. Now at first glance, if you look at this, you will say, okay, they've got the same sign and they are both perfect cubes, so we may as well go ahead and factorize it. But what I would like to do in this instance is, instead of going straight to factorizing, I would like to take out a common factor. Now, our common factor here is going to be negative 1. I remain with p cubed plus 216. Next, I can open my small bracket and my big bracket. The small bracket always takes the sign of the original expression. This is minus, this is plus. Once again, cube root of p to the power 3 will give you p. We've got p there. The cube root of 216, if you press this on your calculator, you get 6. So we have 6 there. Now for the terms in the bigger bracket. We are going to have, okay, this is p squared. P squared is just going to give you, whoops, wrong color. P squared is going to give you p squared. So we've got p squared there. Next step is to multiply the two terms in the first bracket. So p times 6. This is going to give you an answer of 6p. So 6p. Let's put 6p there. Lastly, we need to square the last term in the first bracket. So 6 squared. This is going to give me an answer of 36. So I put 36 there, and I'm done factorizing it. Wonderful. Life is great. Let's look at the last question for this video. In our last question, we've got p plus 3 cubed minus 1. So a difference of 2 cubes. Let's look at it. I'm going to open a new sheet of paper for the sake of space. So there we are. Our question is p plus 3 cubed. This is a terrible 3. Let's see what we had in our original expression. Minus 1. Believe it or not, this is a difference of 2 cubes. So I'm going to have a small bracket and I'm going to have a big bracket. Small bracket takes the sign of the original expression. I'm going to have plus and plus there. Okay, let's get into it. The cube root of p plus 3 cubed is just going to give you p plus 3. So I'm going to put in brackets here p plus 3. Then the cube root of 1 as 1. So I'm just going to put the 1 there. Next step is I need to take the first term in the small bracket. So I'm going to take p plus 3 and I square it, and I'm going to leave this as p plus 3 squared. So let's write it here in brackets as p plus 3 squared. Next step is I need to multiply the two terms in the small bracket. So I've got p plus 3 times minus 1. This is going to give me negative p plus 3. Sorry, we're supposed to ignore the signs here. So this multiplied by 1, this is just going to give me p plus 3. So I'm going to put the p plus 3 there. Then lastly, I need to take the last term in the small bracket and square it. 1 squared is just 1, so I have 1 there. This is my final answer. I am done factorizing. If you want to, you could expand the bracket. So for example, you could expand the p plus 3 all squared. And once again, for you to be able to do so, please have a look at our video on products, grade 10 products. I will put the link down in the description below so that you know exactly how you would go about multiplying out these brackets. I hope that this video was educational. I hope it was informative. I hope you guys have learned something new and that you also enjoyed the content. Please don't be afraid to get into the comment section and tell us if there's something that you did not understand or something that you did not enjoy. If need be, we can always re-upload the video or create another video expanding on what you did not understand. Other than that, please like the video. Please subscribe to the channel. Click on the bell icon so that whenever there's a new video, you never miss an update. Until then, we shall talk in the next video. Enjoy the rest of the day. Ciao.